Hi, I'm Ehsan Allymehr, and today I want to present my work on the effect of enhanced surfaces and evaporation of hydrocarbons. What we have been working on here has been a part of the push for a more widespread adoption of natural working fluids in heat pump systems, and hydrocarbon is a part of this fourth generation natural refrigerants. The systems with hydrocarbons are usually more focused on small-scale systems, and the major challenge with the hydrocarbons has been the low allowable charge in systems because of the flammability concerns. As most of the charge in system is in the liquid phase in the heat exchangers, it's imperative to reduce the volume of heat exchangers as much as possible. What we have done here is to compare the evaporation characteristics of three fluids, namely propane, which is R290, isobutane, which is R600A, and propylene, which is R1270. And we've tested these in two microfilm tubes that you can see a picture of it in here, and one smooth tube. The microfilm tubes have quite different surface geometry, and because of this they have a rather different characteristics. We have used different parameters to depict the effect of enhanced surfaces. These three factors were enhancement factor E, portraying how much higher the heat transfer coefficient is in a microfilm tube than in a smooth tube, penalization factor P, for how much higher is the pressure drop, and efficiency index I as a relative relation between these two factors. As you can see in the graphs, in higher mass fluxes, there is a lower increase of heat transfer coefficient, while the pressure drop increase is relatively the same. Therefore, the use of microfilm tubes is more beneficial in lower mass fluxes. Regarding the use of correlations and predictive methods, we found out that while there are reliable correlations for the smooth tube, the results vary considerably for microfilm tubes based on the used tube and the fluid. For example, in here you can see that the correlation of Diani, while being more or less reliable for the data of MF1 tube, has huge errors for the MF2 tube. This is also the case for other correlations, as you can see in the correlation of Rollman and Spindler here. Thank you for your attention. I will be available later to answer any questions you might have.